Hypothalamus Artificial Intelligence, HAI. Digital transformation powered by real-time autonomous and intelligent algorithms. OPTEX-GAMS is the computer platform developed by HAI for general algebraic modeling systems, GAMS, users. As a GAMS business partner, HAI has linked all its OPTEX's mathematical methodologies and technologies to the development of highly complex mathematical optimization models using algorithms to offer to the end user a total, automatic integration between them. The video presents the connectivity of GAMS optimization with OPTEX, optimization expert system, and the services offered. This is the process that is followed by HAI GAMS to offer our customers the enterprise-wide optimization systems as part of Industry 4.0. HAI operates as a knowledge factory in highly complex mathematical modeling. Its main objective is the monetization of its intellectual property, making win-win commercial alliances. For this reason, one of HAI's main interests is to make joint ventures with GAMS optimization partners to go to market. Knowing adequately the different technological alternatives to implement highly complex models, using the high-performance technologies produced by GAMS, HAI offers the connectivity OPTEX-GAMS. The solutions offered by HAI can support the growth of startups, spin-off companies or established companies, to offer solutions to their end users, as part of the digital transformation of companies. OPTEX, mathematical modeling using cognitive robots, is a new vision of mathematical programming that makes mathematical models as Lego models. The modeler assembles the mathematical model integrating modular mathematical components and not based on programming.
The goal of OPTEX is: the best way to make software is to have and to do it. The HAI approach is aimed to develop mathematical models using cognitive robots, that eliminates the tasks of computer programming, since the robots takes care of this process. This enhancement the mathematical modeling capacity of the professionals and produce error-free code.
Then, OPTEX is a exacortex for mathematical modeling, that enhances the capabilities of modelers, by assuming the responsibility of carrying out all systematical tasks. The final user benefits from all these capabilities, since the algorithms to which he can have access are, in accordance with the state-of-the-art of augmented artificial intelligence, mathematical programming plus artificial intelligence, that supports artificial hypothalamus, as the modern form of the decision support systems for Industry 4.0. OPTEX, the Artificial Intelligence Optimization Platform, is a cognitive robot and expert system developed and maintained by HAI, beginning in 1990. OPTEX is a rapid application development tool, focused on the design, implementation, startup and maintenance of artificial hypothalamuses, conceived as a union of mathematical optimization models with information systems following the modern guidelines of object-oriented programming, avoiding the intensive use of resources for programming computers and the development and maintenance of computing solutions based on the concepts of high-complexity mathematical programming. Making very large-scale models by the traditional way, using a computer programmer, it is an impossible way, because the programmer only can write a limited number of lines of good source code per period. Maintaining these models can be more complicated than doing them, if more than one programmer intervenes in the process.
OPTEX is capable of producing infinite lines of perfect source code per period.
A computer programmer produces limited lines of good source code per period. In addition, like any artificial intelligence tool, OPTEX has a known and permanent methodology, while programmers change the method in each new program, which makes the software very complicated to maintain.
OPTEX generates the large-scale algorithms required.
For implementing complex mathematical models from MS Word, the stages are: first, convert the algebraic model to a formulation in MS Word, in the form of tables. Second, convert MS Word tables into CSV files in standardized ANSI format. This may require an intermediate step that goes through MS Excel tables. Third, upload the CSV files to the OPTEX database. This process is carried out with the support of OPTEX, which automatically validates that the mathematical elements are correctly formulated. Fourth, generation of the source program of the mathematical model on the selected computational platform. The second step may be shortened, loading the information from MS Word directly to OPTEX, using the MS Windows clipboard. The future OPTEX load process will be a more interactive activity via web access. HAI believes that this process could be called OPTEX-GPT, because it will be based on generative artificial intelligence. OPTEX performs the automatic generation of industrial information system data models. This is taken advantage of by OPTEX to automatically generate the data model of the IDIS, and the user visual interface, based on a system of holograms for the data capture screens. The first point to consider is that the indices of mathematical models define the entities of the data model. Additionally, the relationships, sets and indexes, parameters and indexes, variables and indexes, and restrictions and indexes define the relationships between IDIS entities. Based on these laws, OPTEX can automatically generate the IDIS data model, considering the sets and the parameters to be read. OPTEX manages a metadata model that, automatically, generates a user interface that includes an Explorer menu to navigate the tables of the IDIS that can be resident on various types of database servers. Second, all the shell windows that contain the master and the relations tables for each entity. These components, browser menus and windows, are not associated with any program. They are generated by OPTEX, online, when the user requires them. To store all the results of the runs of the models, OPTEX automatically generates the structure of an extended information system, based on the scenario and scenario families concepts. Regardless of the programming languages, the models connect directly to the IDIS database, by means of SQL statements. Because the IDIS data model is open, the end user can connect it to any other application developed by a third party, this for any input-output data. The artificial brain is the evolution of DSS under the Industry 4.0 revolution, that is conceptualized as a set of mathematical models, that exchange autonomously information between them, working online, using distributed optimization. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. This is how the human brain faces reality, using multiple models of reality, acting permanently in parallel, to make decisions. There are multiple points of view for building an artificial hypothalamus, but they should all produce the same results. Linking OPTEX-GAMS to optimization technologies. For OPTEX-GAMS connectivity, the mathematical models are stored in the OPTEX warehouse and from there the GAMS program is generated. Connectivity to the user's databases is done through Open Database Connectivity, ODBC, and queries through SLQ statements. In GAMS, the solver to use is selected. The program can have access to advanced GAMS concepts. Examples: disjunctive programming, two-level optimization, mathematical programs with equilibrium constraints, and more. The screenshot shows an example of a GAMS program generated by OPTEX for the GSDDP, a variation of Bender's theory. In this case, GAMS is connected to GUROBI. The services offered by OPTEX are: automatic GAMS model generation, automatic generation of SQL connectivity to mathematical model, data model, automatic generation of large-scale optimization models, using Bender's and Lagrangian relaxation, automatic expansion of submodels, automatic coordination of parameters and sets of the submodels. GAMS Engine is an API designed to run in cloud environments. It's an enterprise-grade system that runs on a server and offers features like high scalability, load balancing through a job queue, continuous updates, and much more. The GAMS engine automatically schedules jobs and assigns them to a GAMS worker available to solve them. Moreover, it comes with a powerful user management system that allows you to restrict your users' activities according to your organizational hierarchy. The GAMS engine can not only be controlled by a Miro application. Thanks to the use of OpenAPI, clients are accessible in various programming languages. The image presents the components that have to do directly with optimization, whose capacity must be designed, and that generate costs that the user must assume. The first element to consider is the multi-core and multi-threaded CPU, its architecture, and the software components it stores, which are presented below. The diagram presents the OPTEX-GAMS connectivity. It is based on two OPTEX processors. OPTEX client that allows access to the databases of the OPTEX expert system. OPTEX processor, which generates the GAMS programs. For database connection, OPTEX uses two approaches. First, using includes data programs, automatically generated by OPTEX and identified with the .opt extension. Second, it directly accesses a relational information system, implemented in a SQL Server type. In this case, OPTEX directly generates the SQL statements that will be included in the GAMS program. This is the fastest way. The screenshot presents SQL connectivity in a GAMS program. All result tables are stored in normalized relational tables. The results are delivered in two forms, CSV files and, if the user wishes, directly to the SLQ server. CSV files are available to the user immediately, while server-side files have significant access time. On the other hand, the connection between programs that share data is done through CSV files, since this process and the SLQ processes can be done in parallel on different servers. The best way to make software is to haven't to do it. The structure of the programs implemented by OPTEX is always the same. The diagram presents the structure for the solution of a standard, monolithic problem that internally has 5 stages. Reading data from the information system, processing of parameters and reading sets, to produce the parameters and sets of the mathematical model, optimization of the mathematical model, post-processing of results, and storage in the information system. If there is an inner loop, it will be reflected in the process. Below is the program generated by OPTEX, including summary explanations. Model header and indexes declarations. Alias indexes declarations. Time standard parameters declarations and reading. Read sets. Declarations and reading. Includes read parameters. Special parameters processing. Read parameters, default values. Processing of parameters and sets that must be calculated. OPTEX resolves the correct order for declaring parameters and sets, taking into account the relationships between them. Model variables declarations. Objective function variables declaration. And model variables bounds. Constraints declarations. Initial stock constraints declarations. And objective function equations declarations. Constraints algebraic formulation. Constraints existence conditions, and variables existence conditions. Objective function equations. Creating CSV files model variables. OPTEX-GAMS offer highly complex mathematical models for end users. The table shows the available solutions implemented in OPTEX and whose mathematical problems can be solved using GAMS.
The solutions cover multiple economic and industrial sectors. On LinkedIn you can obtain the videos related with mathematical models to end users, and the technical documentation about them. OPTEX is geared towards building multi-problem mathematical models, which are the essence of the artificial brains, that are part of enterprise-wide optimization systems. OPTEX uses its expert system for the mathematical modeler to develop complex algorithms, without performing computer programming tasks, because it stores all the implemented models in a structured way, which turns the creation of models into a Lego game, joining and dividing problems.
Like Herbert Simon, Hypothalamus Artificial Intelligence believes that the computer-based mathematical modeling is the greatest invention of all times.
Thank you for your attention.